Hello. We'll give people a few more minutes. Friend. Hey, Oliver, stop it. Sorry, my dog thinks that since I'm on a conference call, he can do whatever he wants. Light numbers again today, so we'll give people just a few more minutes to get logged in, and then we'll get started. But if it's small, if it's a small group of people, then we should be able to take a few more questions. Hey, stop it. Oh, yay, one more. Okay, I'll go ahead and get started today. So see, everybody's got theirs on mute. So just make sure that if you have a question, to take it off of mute and speak up a little bit. It's a little windy out. I'm at home. It's a little windy out, so the sound might not be coming through. So happy Wednesday, everybody. Had a few things that I just wanted to mention. Some questions had come up, and then we'll look at some analyses, and then I can take questions whenever you have them. Learning checks 5 and 6 are muted right now. As I had made the announcement, one of our TAs had an exam, which I think was yesterday, actually. So he should be grading right now. and we'll get those back to you. As was made an announcement earlier in the semester and earlier in February, the Learning Check reflections for the first half of the class will be open through spring break, so you will have plenty of time to put those reflections back in. There won't be, once the grades are released, you cannot take the quiz again, but you can certainly do the reflections. And somebody let me know, I need to make a note of that Learning Check, that there's no submission for the team hypotheses right now. I'll fix that. That's, for whatever reason, Canvas's default is no submission. I think its default would be online submission, but anyway, I'll get that fixed so that those can get turned in. There were a lot of questions this week on the midterm and what the format of the midterm would be. The format of the midterm will be very similar to what you've seen in the Learning Checks. So there will be some multiple choice, there will be some fill in the blank, there will be some analysis that you need to do and type up. You will be able to print out a Word document so that you can actually work on the midterm independently, and then you can log into Canvas and enter in your answers. So there's no time limit, but it will be online. It is open book, open note. So, and it's cumulative, though I'm not going to ask you a question that's associated with every single thing we've covered. If you want to prepare for the midterm in advance, a good thing to do is to go back and look at the module objectives for each module. Those are the things that we've really highlighted that are important for you to either know or to understand or to be able to do. But you won't see anything new on the midterm that you haven't seen before. You'll just see them combined together in a single analysis, so to speak. So don't forget about the first couple of modules where we talked about what samples were and what populations were and what the definitions of the types of variables are. It's not just to jump straight to the analysis. That's something that everybody loves to do. They say, oh, it's fit y by x. But the problem with that is you might write it up. And when you go to make your table, you realize that you skipped over the initial summary statistics. You didn't do the distributions and look at the ages, and you get to the end of it and you realize that you have somebody who's 344 years old in your data set, which is not a real value. So it's either an error, well, it's an error actually, but it may be able to be fixed. So say they were supposed to be 34.4 years of age. Those are the kinds of things that you need to pay attention to before you get to the final t-test or ANOVA, so that you don't have to back up and start over with that. So again, the midterm will be open book, open note. There'll be a single Word document that you can print out and the data set that you can download to answer the questions in a Word doc before you then open Canvas and you can do the answers. Now you only get one try on the midterm. There are points where we need to see how you're doing on your own, and we'll address that, the scoring on the midterm and those types of things when the scores are back. And this will be due before spring break. So if you don't have any reflections to turn in, then your spring break will just sort of be a free week, which is nice. So the midterm review materials will be released by Monday morning. So you'll have a week for the midterm review. There's no new materials being released before. So once you complete module 7, the midterm reviews will come out and you will have the second week in March to do your midterm. So there's plenty of time to go back and reflect on that. Any questions on the midterm before I move forward? No? Okay, fantastic. I had a question today from somebody about how do I keep track of my analyses? And that's a really great question. I'm glad that people are getting to that point. So when you open the Learning Checks and you have a data set, how do you keep track of what you've done? Well, something that I've come to over my 20 plus years of biostatistics practice, and of course Word has decided to be slow, is that I create myself an analysis document. So let's see here. I'm gonna share my desktop here. Can you all see my desktop? I'll actually need somebody to answer.
Yes, ma'am.
Yes. Fantastic. For some reason, the green bar isn't showing around my screen, which usually lets me know that there's a share going on. So what I've started doing, which I started doing a long time ago actually, was opening up what I have is a summary report document, and I start one for every project, for every analysis that I do. And this pertains to your homework as well, or pertains to your midterm. And the reason being here is that I generally don't have, 8 hours of my life to sit down and do an analysis. Most of my analytical projects take place over several days of time. So I have an hour here between meetings, or I have an hour after class, or I come home at night or on the weekends and I work on it. And so there's a lot of stopping and starting. And that may be true of your midterm. You may not have 2 hours to sit down and dedicate it. You might want to do it in pieces. And so one of the ways to keep track of what you've done, what your output looks like, any questions you have, is to just start a blank document. And so I thought I'd give you an example of what mine looks like. And sort of this will be helpful for your data briefs as well for your team, is that I have a summary report here. Let me make this just a little bit bigger so that we can sort of walk through this and you can see a little bit better about what I do here. So we'll have who prepared by. Some of our analysis or summary reports have multiple people. I'll always put the current date of when the most recent day that I worked on, and then what are the data files, and for me, where are they available? So is it on a cloud drive? Is it on a server? Is it on Box? So it's not just the file name, but it's also where it can be found. And for statisticians, that's actually really important, especially if we have more than one person working on a project, then they know what the data is. Or when you get into research and you do an analysis and you write it up and you submit it for publication, it can take upwards of 6 months before the journal gets back to you about the manuscript. And they may request different analyses, or they may have other questions, and being able to go back to a document like this is very helpful. So for example, on your midterm or your data brief, once you submit your preliminary analysis for your data brief, if I come back with some suggestions or comments, you don't have to start your analysis all over. You can go back and say, oh, here's what we did. And one of the examples here, so I've got project details. This is set up for a clinical trial. So we've got the trial design. What's the intervention? Do we have different study visits, or is it simply cross-sectional? What are our outcome measures of interest? So this is one of the questions that you have right now, is what is your outcome measure? Remember, that's our Y variable. So if we're looking at a group means situation and we want to know if there's a difference in the BMI by sex, then BMI is our outcome measure. I have eligibility criteria here, but you could actually list where the data came from, if it's a secondary data source, or if somebody sent it to you, who's in the data. Here's an example of data coding. So on your data dictionary, remember the code books that we have, and let me pull one of these up here. The Burfus code book that we have is huge, right? It's 137 pages. Some of the other code books are a little bit smaller, but all the Burfus code book does is take your data from the raw data to how the categories it has. But as you've seen, when we looked at general health in one of the learning checks, one of the questions wasn't about the 5 groups, it was about fair and poor versus everything else. So the Burfus code book will get you from general health to the 5 groups by taking out missing. But when you analyze it, you might be analyzing it as 2 groups. So having a place where that's reported, and this is just an example from another study that I had, where you can see here that the data coded something 0 for no and 1 for yes. But actually, when we had to create the score, you got 1 point for no and 0 points for yes. Don't get me started on who decided to code it that way. But you can see this is what we mean by a data dictionary, or the coding, because this, the Burfus code book may not ultimately be how you report it in your data brief, until you'll want to keep a record of that decision or how it's used. It'll also help each team member, since each team member should do the analysis for the data brief. It will help you know what you did, and you can compare it to another team member if they made a different decision. And then I'll include a basic section on the analysis details. This has a lot of analysis details. This was from a large study. For you all right now, you would have mean and standard deviation, median and range, perhaps the interquartile range, and perhaps reporting some of the demographics by percent N or N%. And then so far in this class, we're at the t-test, and you can get to the ANOVA, and your t-test might be paired or it might be a 2-group. From there, I always have a consort for participants. So if you go back to the announcement I made about how to count your people, that figure that I showed in that announcement is called a consort figure, and it will take you, say, from, let me get this table out of the way. It will take you from this situation where you have 441,000 observations to the number that you end up using for your analysis. So you'll have physical health days that are missing. You'll have some of the general health days that are missing. So you won't have, if you were using this data set for your data brief, you actually won't have 441,000 people that you do the analysis on. This is the survey response number, but you'll need to actually report what your analysis number is. Someone asked me, how can we find that if we have lots and lots of variables? And there's a relatively straightforward way and jump to do that. And it's in your table summary. So if I'm looking at this data set and I go to tables and summary, and say I want to know, I'm going to be looking at sex, and I'm going to be looking at mental health days, and I'm going to be looking at physical health days, and I'm going to be looking at general health in the 5 groups. I've put all of them, so I went to tables and summary, and I put all of those in this group here. And if I press OK, it's going to take a minute because this is a really long, really large data set. What you can see here right up at the top is that there are 57 rows that are missing all 3 variables. So this is missing, that's missing, this is missing. There are 57 rows that are missing all 3 in terms of male. And if I go down here, this is a pretty lengthy one. It doesn't look like and then I've got another 53 that are missing with female. So let's simplify this a little bit since our male and females are all present. I'm going to go to tables and summary, and now I'm going to do the physical health days, the mental health days, and the groups, the 5 groups. So I took gender out because we weren't missing any of those. Oh, that's less rows. So now I can see I have 110 people that are missing everything of those. If I was going to exclude any missing, then you could see that we've got, let's see, we're here with missing, that's missing, those are missing, and that's missing. So they're missing any of them. And that's this many rows, and it's about 12,000 if you count up the things here. So when you're doing your data, what will happen automatically if you're doing a fit Y by X is that only respondents that have both the X and the Y will be included, and JUMP will tell you how many counts you have. But if you need to add in a 3rd variable, this table's summary will start to tell you what does the missingness look like in there. And it's really important. The more variables you look at, the harder it is to count. You'd think it's easy, but when you're dealing with 440,000 rows, it's actually gets a little complicated to count things. So when I do a data set like this, I'll include a consort so that I know what my analytical size is. So I may have started with 5,000, but actually I'm down to 3,750 when it comes to my analysis because people have missing data. And that's okay. You just have to be clear about it. Just have to be clear about it. And I'm happy to help any of your groups, help your teams figure that out, but I have to know your variables first, right? So I can't, it's hard for me to, you'd have to be specific about what variables you're including in, which is where you're getting with what's due with your hypotheses. And then also what I have in every summary data set here is a table 1, which you've heard about before, and it will have all of your baseline characteristics. Again, this is from a different data set. You all don't have access to this data set. But you can see here, I've got an all column. So this is overall, and getting overall would be analysis distribution. And then in this particular situation, I've got 3 categories. So you could have education level here, you could have sex, male and female here, depending upon whatever variable you have of interest might be how you break up your groups. But you can see here, I've got an age summary, mean and standard deviation. I also have age as 75 or higher. So this then becomes an N and a percent instead of a mean and standard deviation. I've got the percent female. I have ones for race, ethnicity. So when people were asking, do you need a table for each of the variables you're considering? You don't. You can actually put all of the variables of interest in a single table. And I usually just leave a blank one. I have a template for my analytical summary. What you'll see here also is that while this is 8406, I've got 2 variables here, smoking status and education level and smoking status, that actually have different ends. And so I've indicated here what those ends are. I don't have an analysis part to show you on this on draft, but when I start doing t-tests or ANOVAs, I'll also reiterate what the N is for that when I get to those graphs. So this is one of the ways it's really good to keep your analyses straight. And one of the great things about this is that you can cut and paste from JMP directly into this. So you can save your output from JMP into a Word document. And it's very easy. So let me show you how to do that. So here's our BRFIS general health data set. And let's say I wanted to do an analysis of sex by the general health, or sorry, let's do sex by the mental health days. So I would go to analyze, fit Y by X. It would put my sex in the X factor, and I would put my recoded mental health days in my Y. And so JMP tells you here that since I have a nominal variable, this little red histogram, that I'm going to be getting an analysis in this section. And I have a blue outcome, little blue triangle outcome, which means I'm going to be in this part. And so I'm going to get a one-way output. So I'm going to get a one-way analysis of variance. We only have 2 groups, so it'll ultimately be a t-test. But that's where I am here. So JMP will tell me what I'm going to get. I press OK. So if you recall from the module notes, JMP gives you a very sort of blank template here when you're looking at a continuous measure by 2 categories. And you need to tell JMP what you want from it. And so we have our outcome of mental health days. This gray bar is the overall mean. This gray bar is the overall mean of mental health days. And this isn't super helpful to me because we have a floor of 0 and a ceiling of 30. And we can see that we have people that report 0s and 30s. So what I really need JMP to tell me is what are my quantiles? So what are my median, minimum, maximum? And then also what are my means and standard deviations? And so this is my summary statistic for these that would go into, say, this table. If I had male and female as my columns, and I wanted to put mental health days here as a row, I would then take this information and enter that into my table. If I want to save this, just go to this big fat plus up here. So let me see if I can get jump to circle. Oh, this big fat plus. So right now I'm on the pointy arrow, but if I go to the big fat plus and I click here, it's going to highlight it. I can copy it. And I can go into my Word document and I can paste it. Ooh, that's really big. I'm going to undo that. And I am going to paste special. No, hold on. Let me undo, edit, undo, paste. And I'm going to paste special, and I'm going to paste it as a PDF so that it will come in a little bit smaller. If you're not super word savvy, pasting something as a picture as a PDF will help keep it small. I have, so that you guys can see this better, my jump output set at super high font size. So if I just paste it in here, it's going to show up as huge. But that's fine. So this saves. And so now I won't have to go back and do this again. It tells me how many males, how many females I have. I've got my mean and standard deviation saved, and I have my median, min, and max saved. There are also other ways which you can Google if you'd like to get jump output into your Word document. If I want to do a t-test, then I can ask it for the t-test here. Can somebody tell me on a t-test here, what's my question? What am I trying to answer? Anyone?
If there's a difference in the average number of poor mental health days between gender, among gender.
Yay! Kenneth, I'm throwing you fictitious candy for the right answer.
Yes, ma'am. Thank you.
Right. So the question here is, or our null hypothesis would be that there's no difference in the mean number of mental health days that have been reported by gender. So let's actually write this down. So in my analysis, I can put my null hypothesis here and say there is no difference in the number of poor mental health days by gender. And my alternative hypothesis here would be there is a difference in the number of poor mental health days by gender. And so this ultimately is my research question here. I'm trying to determine if there's a difference in the number of poor mental health days by gender. And the t-test will answer that question for me. Let me go back to my pointer here, make this a little bit smaller so this is more centered here. And so the t-test, and there's two t-tests available. The regular t-test here assumes unequal variances, so it lets the male group and the female group have their own variability. It doesn't look like from this that their variances are that different. So you can also ask it for a pooled t-test. Either one is fine. Either one is fine. This assumes equal variance, so it would use one variance for the test rather than letting males have a variance and females have a variance. Either one's fine. And in fact, they're going to be very similar because our sample size is so very large here. Okay, so let's look at the results here from the t-test. So what it will tell us is the mean difference, right? Remember, we're looking at days, So the mean difference here is just shy of 1 day of poor mental health difference. And you might say, well, how do I know what they're doing? Well, first of all, it tells you female minus male. And my response or my result here is positive, which means that females reported more poor mental health days than males. But you can also see that right here. that tells you this in the means output. So I've got 3.7 poor mental health days on average reported for women and 2.7 for on average for men. So if you round this up, we're looking at a 1 day difference, one more day by females. Here's our T ratio. Does anybody remember what anything like a T score? What are large T scores? Anybody? How many standard deviations away from this, the center is unique, is something unexpected? So if we go back to our distribution that looks like this, if it's centered on 0 and we have a standard deviation of 1, how many standard deviations away is considered unexpected?
3.
Yeah, 3 definitely would be.
And I think 2 is accepted as well.
Yeah, 2 or larger is generally considered to be like, so 3 for sure would be considered to be unusual or evidence of the alternative hypothesis. We have a giant t-test score here, and that's because we have a really, really big sample size. Really big sample size. So let's go back to our hypothesis here. Let me bring this up side by side. So there is no difference in the number of poor mental health days versus there is a difference in the number of poor mental health days. Our observed difference is 0.99690, but that would really end up getting reported as a 1 day of difference. Females higher than males, right? So I'm just making notes for myself so that when I go to write this up, I understand the interpretation at the time that I've done it. I can give my T-score here, my degrees of freedom, which is huge, 434,046. And then my p-value, since this is a 2-sided test, since I'm asking difference or no difference, is this one right here. Is this one right here, because it's the 2-sided. And you know that because it's got the absolute sign around the T. So it's looking for any difference. There is a difference in the number. And so our determination here would be that we have a very small p. We haven't quite covered this a lot, but our determination here would be that yes, we are going to choose HA, and we are going to conclude there is a statistically significant difference between number of days of poor mental health reported in prior 30 days between females and, oops, there's the typing, females and males. And then you could put your T and your p-value in the parentheses here with females reporting 1 day more per month compared to males. And so that's my summary, but I can also go back here and capture this part, since I've already captured the other part, and paste it into my document. Make it a little bit smaller so that I've saved it, so that I know that I don't have to go back and do it again. Like I've got the output and I've got what I concluded, and then I can move on to the next question. I know I kind of went through this a little bit quickly. Are there questions? Anybody want me to back up and show it again? Or you can just wait for the recording and watch it again. Yay, nay. All right, so that sort of takes care of the t-test. If did I hear somebody wanting to ask a question? Nope. So that takes care of the t-test. If we wanted to look at, I'm gonna pull up this means tutorial data here. Let's cancel. So if you haven't looked at the means tutorial data, this was posted under the live Zoom sessions from last week, since there was not one from last week. Here, I'll go and show you guys where it is. Yes, nobody cares, Mozilla. So if you go into the course and go to modules, and you look at there's a means tutorial here if you haven't seen it. And it actually uses the data that we'll look at here in a second. And it walks through basically how you would address this data from start to finish with a number of things. And so in this data, which is pretty simple, we have a race variable, a gender variable, an age variable, weight, BMI, and we have a pre-score and a post-score. So if we have a set of data where each observation has 2 scores, what kind of test is that? Anybody?
T-test. T-test.
It is a t-test. What kind of t-test? There's a name for it. So we have each person has 2 results. We have a pre-score and a post-score. They're paired together, and that's called a paired t-test. So rather than looking at males and females for weight, which we could do, we could look at each person's pre-score and post-score. So you would create a difference here, a difference score. And we'd want to compare to determine whether or not people have changed from their first score to their second score. Or if we had this here, you could say, did their weight change from time A to time B? That's called a paired t-test. And in that situation, we'd be creating a new score. And so to create a score, a difference score, we create a new column. So I just double clicked over on this outside, or you could go into the columns menu and say new column. And I'm going to call it pre minus post. And I want to create a formula. It's the very first thing in the drop down. And then I want to edit this formula. And this formula is really straightforward. You get the formula window. There's a bunch of options over here, which I won't need today. Here's my variables that are available. Here's some things I can do with them. But this formula is pretty straightforward. All I want to know is the post score minus the pre-score. And press OK. So now I've created a change score. And one thing that I think is really helpful, rather than just calling it a change or a difference, is to actually call it the way that you've done the math for it, so that I won't forget that I did, I did post minus pre. Let's call it the right one here, post minus pre. So that if the score is positive, I know that the post score was bigger than the pre score. And I can see that right here. Post score is 2, pre score is 1. So my change, it went up 1 from the pre-score to the post-score. If we look at this one, this had a 2, both pre and post, so the change is 0. Does anybody know what our question here would be if I was assessing the change score? What do I want to know about that? It's not very different from this. So instead of asking if there's a difference in the number of poor mental health days by gender, what am I asking here?
If there is any difference between pre and post scores.
Right, so my null hypothesis is there's no difference between pre-score and post-score. Another way to say that is that there's been no change from pre to post. And then our alternative is that there is a difference or there is a change. And since we're just asking overall, we're not looking at it by gender or by race, we're just asking overall. The way to do this one is in the Analyze menu, Distribution, and put my pre-post here, and press OK. And so I get the distribution that I've seen before, which is really helpful. So first of all, I would want to put a table in here of the pre-scores and post-scores so that I know where people started and where people ended. And then I would also want to summarize the change score. And that gives me all this information here. And then in order to test this, so I could even say I did analyze distribution. And then now what I want to do here is I want to test the mean. So I actually want to ask JMP, is this mean change score of 0.71, is it different from 0? Is there a change? Is this significantly different from 0? Little red arrow, test mean. So in the notes where it talks about a z-score versus a t-score, if you knew the true standard deviation, which we almost never do, you'd enter that here, but if you leave it empty, we'll just leave it empty and it'll do a t-test. And I press OK. So here's my t results. Here's our little figure again. So again, somebody had said before, an interesting t-score is something that's 2 or higher. That's something unexpected. That's something that tells us we have evidence toward the alternative hypothesis. Our t-score here is rather large again. And so we would actually conclude here that there has been a change. So I would say, let's see, conclusion. The change score is significantly different from 0. And I could put my t and my p-value in here. And then I could say post scores were 0.71 points higher than pre-scores. And again, I could actually copy this whole thing and stick it in my document so that I have a record of what I did. And then I would save it. So if you're working on the midterm or any analytical project, the next time that you go back to it, you already have all this stuff. You don't have to refresh your memory by opening JMP and doing it again. Questions about that?
Where we can use the pre and post scores, like in the continuous variables, like I mean, kind of values, like testing blood sugar level or like any, I mean, creatinine level, like that.
Yeah, absolutely. So if you took my blood today and it came back, you know, if you have a diabetic person and you get their HbA1c today, and then you put them on an exercise or a diet regimen, or you change their medication, and in 6 weeks you take their HbA1c again, you can certainly assess that with a change score. So anytime that you have the same value measured on someone twice and you want to assess the change, you're pairing those values, and it's a paired t-test.
Okay, thank you.
Anytime that you have two different groups, males and females, and you want to compare males and females, that's simply a t-test. We haven't paired scores together. We're just comparing the mean from males and the means from females.
But then, like, what will be the post and what will be the pre-score? Like, if you're
There
comparing.
is no post and pre when you're looking at a straightforward t-test. You've got a group of males with weight and a group of females with weight, and we're comparing males and females. If I want to compare males and females on my pre-post, then it's just a regular t-test on my score, on my pre-post. So that I could do with fit y by x, put my change here, put my gender here. So this is my my categorical, this is my continuous. I'm going to get a one way. I'll press OK. And back to my figure here. So this is on the change score, and I can ask it for the pooled t-test. So rather than asking if the pre-post score is different from 0, in this situation, I'm asking if the change is different by males and females. So I'm not asking, has the pre-post changed? Is it different from 0? I'm asking if the change in women and the change in men is the same or different. Do you understand the difference between those two questions? Let me type it out for you. So in a paired t-test, asking, bring this up here, if the pre minus, or the post minus pre is different from 0. In the t-test, I'm asking if the observed change is different by sex. So you could also say that is if the change in score for females is different from the change in scores for males. So the paired t-test is simply asking if there's a change or not. And the regular t-test is asking if there's a difference in groups. And in this case, it's telling us no. That while we saw an overall change from pre to post, which we looked up here, that first question, while the overall pre-post change was significantly different from 0, there is no difference in gender with the change. So males and females both changed just about 0.71, females 0.715 and males 0.714. So this right here, this observed difference of 0.71 is a significant change, but males and females exhibited about similar changes. Questions? I didn't have any other questions that were submitted today from anyone other than what we've covered here. So if I don't, hearing none, I will say thank you, and the recording will be up later this evening. Okay. Thank you, everybody. Have a good night. Okay, let's get this share. letting me end Zoom.